All right, so we've got this circuit, and I want to briefly review the bit of circuits that we've done so far. A bit that explains what's going on here that you should have been reading in the text. All right, and then we're going to walk through this. This is a circuit you could see in your house: a space heater, a microwave, and a lamp. And you're powering it off 120 volts, which usually it's just plug in the wall, but in this case it's a battery. And so we're going to ask what the total current is and what the total resistance is. Now, if we start from the beginning with defining a potential difference, defining the current, and then we ask, well, what happens when you have current flowing through a thing? What you get is what you discovered in the lab, is that the voltage and the current and the resistance are directly related. You get something like this, which is Ohm's law. Voltage equals current times resistance. And if you remember, the voltage, the potential difference, is energy per unit charge, and the current is charge per unit time. So this is energy per unit time as a power. So you get a power law. So you can figure out the power from the voltage and current. And from Ohm's law and the power law, you can get these two statements for things that act like resistors. And that's everything we're going to deal with. Right. So we're going to try to solve the problems with just these things. And that's all we need for this part. Right. But we also need, how do things add up? And in the lab, you saw things add in series, so you just add them up. R1 plus R2 plus R equals the total resistance. But in parallel, because you're giving it more ways for the current to travel, more paths, you end up having this 1 over R relationship. 1 over R is 1 over R1 plus 1 over R2 plus, and so on. So we're going to use those things, and we're going to walk carefully through doing that. Right. So there's our problem again. And this is what you should have in front of you as you're working. But I've drawn it out here like this so I can work with it. And so we're going to start with the first one, right? We've got to find the total current, so we've got to find what goes down through each resistor. Right? And then we also have to find these resistances eventually. And what we have in these two cases is power and voltage. And so we can do power is voltage times current, and convert that. I is power divided by voltage. And then we also have Ohm's law, which is separately true. If you remember from the lab, we can ignore everything going on in the rest of the circuit and deal with one part of it. And then we can ignore other chunks and just find the second chunk. So we're going to do it one step at a time. And so in this case, R is going to be V over I. And now there's multiple ways you can rearrange this. It's just, I'm going to find the current first and then the resistance first. And so for R1, right, then the current, and I'll label this current 1, is 1500 watts over 120 volts. And we check our units, and that'll end up being current. And so we'll have 12.5 amps. And then the resistance is going to be 120 volts over 12.5 amps, and that is 9.6 ohms. So we're going to remember these things. All right, this is 9.6 ohms, and the current through here is 12.5 amps. And it helps to draw this, if you're certain that it's right, draw it on your picture so you know how things are going. So there'll be another one here and another one here eventually. Pause, and resume. I'm still not over this flu quite. I'm nearly there. So we're going to find R2 the same way. R2, I'll move up here a bit. Trying to figure this out on the fly. I'm doing everything on my phone, and It's not exactly straightforward. R2 is going to give us I2 is 600 watts over 120 volts is 5 amps. And R2 is 120 volts over 5 amps. That is 24 ohms. Right? Check, make sure the units make sense. So we're going to put those things in. This is 5 amps and 24 ohms. Now we have R3 already, so we just need a current. Right. So I'll do R3, and I3 is, right, the other bit from Ohm's law, we have I is V over R. So I want to use that as well. So I is V over R, which is 120 volts over 10 ohms, and that is 12 amps. All right. And so in red here, circling all the currents, and in green, right, so we have the 3 sets of numbers that we need. And so now we're going to go and find totals. Right? So the current is fairly easy. I total. This is just stuff splitting in branches. So we're just going to add these up. And so this is going to be 12.5 amps plus 5 amps plus 12 amps. And that is 29.5 amps. And now we're going to find the equivalent resistance. And there's 2 ways to do this. The easy way is, once I know the total, then I can apply Ohm's law. R is V over I is 120 volts over 29.5 amps. And I haven't pre-calculated this yet, so I'm going to check. 120 divided by 29.5. And what I get is that this is 4.0678 ohms. And, lots of sig figs, so we'll cut it down. It's 4.1 ohms, because that's the precision that we can deal with. All right. So I'm also going to run this calculation using the parallel resistance rule. All right. And so if you remember, the parallel resistance rule is 1 over, the parallel resistance is 1 over R1 plus 1 over R2 plus, and over here we have 1 over R3, and that's our 3 terms. So we'll step through it. 1 over parallel resistance is going to be 1 over 9.6 ohms plus 1 over 24 ohms for R2 plus 1 over 10 ohms for R3. All right, now remember, what I'm doing is I'm writing 1 over RP on the left each time. All right, each of these are equations. They're not just one following after the other like I might normally do. And so when we do that, and we go and we sit down and calculate, these things are just numbers. You use the inverse function on your calculator. Mine is there. But you just do like 9.6 inverse. Or you do 1 divided by 9.6, and you do all the parentheses. So you need to be careful of doing that. But when you do this, what you get is 1 over this parallel resistance is 0.24583. And your units, everything in here is ohms on the bottom, so it's 1 over ohms. Now we're going to invert this, right? And that means that the parallel resistance is going to be 1 over this number, 0.24583. And our units are ohms. And this is, lo and behold, 4.068 ohms. And of course, a little bit of round-off error between friends never hurt anyone. So this is the parallel resistance. So that's our total. And so that's our answers. Right? We have I total is 29.5, and R total is 4.1, and that's what we got from going through it this way. So sometimes you have to go through it this way. You have to say, here's the parallel formula, fill in the numbers. Sometimes there's enough information in the problem. If the problem's consistent, you can say, I know the total current and the total voltage, then total resistance has to come from that. All right, we'll do another problem in a minute.